Hey everyone, so this is the next video in our series where we are understanding each and every question that I had explained in the Java backend developer mock interview. So we are still at mock 1 and round 1. So you see there are different topics: core Java, data structure, Spring framework. So this is the first question under the category of the database, where we are going to explain the difference between SQL and NoSQL databases. So let's go to that. We are going to understand this SQL and NoSQL databases. Quickly jump to that. So differences can be categorized into particular points that I have summarized in here, that these are the things that we are going to understand the difference. So first difference: data model, schema, scalability, transaction supports, query language, use cases, and what are the different examples like the providers. So, and the reason for putting this under a category is, like, whenever we are evaluating in any databases, these are the basic characteristics of the database that we should look for, that what data model it provides, what schema it provides, what are the scalability options that are available with that database, transaction it's supported or not supported, what kind of query language that I can use to put the data and query the data, and what are the use cases that this database is going to support for us. So under these points we are going to understand the difference in very detail. So first one is the data model. SQL, the full form of the SQL is structured query language. We all understand, right? Databases they're relational in nature. They use a structured schema with tables that has rows and columns, where each table has a fixed schema defined by a set of fields. The relationship between tables are established using foreign keys. Like one table can relate to another table using certain columns that are there, that we call as a foreign key. This is one of the example of that. Whenever we create any table, so this is the syntax of creating that table, because it has predefined schema. Predefined schema means that it has specific attributes, like these are the 4 attributes. They have a specific data type that we have to define in here, and what is the primary key, whether null is on, or there are more syntaxes around it, but everything needs to be defined when you're creating that table. When that table gets created, this is how it is going to look like in the SQL world. This is the structure: user ID, username, email, date join, and these are the respective rows, like values that are there. So later on, if I have to change anything around, we can obviously change it, but as the data grows, like whenever we have huge amount of data, changing this structure is really complicated and creates problem. Coming to the NoSQL databases, so there were certain problems with the SQL databases, and there were certain use cases where it was not best fit basically. That is why NoSQL, that is NoSQL means not only structured query language but extending the SQL basically. So its full form is not only structured query language. So yeah, not only SQL databases they're non-relational in nature. They can store unstructured, semi-structured or structured data, and often use flexible schema. So there is no restriction around schema, like whatever you need you can store it. Data can be stored in various formats, such as they can be stored in the key value format, they can be stored as a document, they can be stored as wide columns, they can be stored as a graph. Based on these types of data formats that they can be stored, there are different kinds of NoSQL databases that are categorized, like key value database, columnar database, document database, graph databases that are there. And this is the representation of the data that it looks like. One row, like we have like this user ID, username, date join, profile. This is what it is going to look like. Later on in future, if I want to add any other attribute, that I can insert by adding that attribute, there won't be any problem. Coming to the next one, like schema. SQL databases, they require a predefined schema before data can be inserted. Any changes to the schema, like adding new column, can be complex and require careful planning, that we just saw. NoSQL databases typically have dynamic schemas, meaning fields can be added without affecting the existing data. This allows for more flexibility and easier adaptation to changing data requirements. So let's say I have a table like this one, and it has like couple of columns are there, and they are stored with this one, right? So, and in future there is a requirement to have one more row in here, one more attribute in here. So what will happen to the previous columns that are there? So they are by default going to be null, and the application should handle that logic, right? But the new rows will contain those data that is there. So that is why there is no schema access. I don't have to, there is no table access, there is no schema access, though I don't have to change anything to insert this new value in here, right? So that is in here. The next one is the scalability. SQL databases are generally vertically scalable, which means increasing the power of a single server. There is a single big server. Vertical scalability, that is, I can add more RAM or CPU to take care of more traffic and to give more power to the database. Horizontal scaling, that is adding more servers, can be challenging and complex. They're not possible. Like new databases, they support horizontal scaling in terms of SQL databases also, that, but they are not as easy that we have NoSQL databases. They are basically designed for horizontal scalability. Scalability was the one problem with the SQL databases, and the huge amount of data, big data that is being generated in new world. So the SQL databases were not able to take care of that one. That is why NoSQL databases were there, and this horizontal scalability was the primary criteria to have that database. They can easily scale out by adding more servers to distribute the data and load, making them well suited for handling large volume of data and high traffic application. Next is the transaction support. Transactionality is a key characteristic that comes with the SQL databases. ACID, atomicity, consistency, isolation and durability, compliance, ensuring reliable transaction and data integrity, that comes with the databases. NoSQL databases, many NoSQL databases sacrifice full ACID compliance for flexibility and performance. So ACID compliance to the ACID properties is the one thing that restricts us from the performance and scalability criteria. Like that is the key characteristics of the SQL databases. When NoSQL databases came into picture and I needed that scalability and performance of the huge scale, so we need to have like sacrifice some of the properties around ACID, like complete compliance to this flexibility. So they do not follow, NoSQL databases do not follow the ACID compliance, but they follow the base model, that is basically available, soft state, eventually consistent, which is more suitable for distributed systems. Like they say, like eventually consistent. Whenever you are doing any data insertion into the database, there is possibility whenever other system is reading, they won't get it immediately, but eventually they will get it. There won't be any data loss, that is guaranteed, but transactionality won't be there. That is the key characteristic of the SQL databases. Query language. SQL databases, they use SQL as a standard query language, which is powerful for complex query joins and aggregation, because we have everything predefined, columns, tables and everything. So I can have complex queries and joins to fetch the data that I need around that one. NoSQL databases often use query language specific to their data model, like whatever provided, like MongoDB uses JSON query language, others are there that uses key value structure there. So based on the database, based on the NoSQL database, what is the underlying data format, based on that query language changes. So let's say if we have 10 attributes there won't be possible to query it from all the 10 attributes. I have to define in advance like what are the keys that I can use to query that data. These are typically less standardized but can be more intuitive for specific data operations. So this is very important to keep in mind, specific data operations. What are the use cases? They are SQL databases best suited for structured data and application requiring complex queries, transactions and data integrity. What are the examples? Financial system, traditional business applications are the examples of the SQL databases best suitability. NoSQL databases, they are ideal for unstructured or semi-structured data, large scale application, real-time analytics and scenarios where flexibility, speed and scalability are prioritized. Example are social networks, IoT devices and big data applications. These are the application areas for the NoSQL databases usage. Let's see what are the examples like of the databases. SQL databases, you see MySQL is there, PostgreSQL is there, Oracle, Microsoft SQL Server is there. NoSQL databases, we have MongoDB, that is document, Cassandra, White Column, Redis, Kivelu, Neo4j, Graph. Other cloud providers like AWS, Azure, Google also provide their own NoSQL databases there. So let's summarize the differences that we have, all that. So you can just take a snap of this one and see what are the high level differences around this one. So that is it about this first video about the database. Difference between SQL and NoSQL database, very important question. Interviews, there is high chances that if you mention that you know the database, so you will get this question that what are the basic difference and what are the use cases, when to use, when not to use, basically. So make sure that you have proper and deep understanding around that one. So that's all about this one. I'll see you in the next one. Till then, take care. Bye bye.